Question is this: using the diagram below, calculate the volume of concrete for trapezoidal drain of 10-meter length. The equation is simple to solve. This is what you're expected to do. We have been given the top width to be 3 meter, the bottom width to be 1 meter. So from here to here is 1 meter, from here to here is 3 meter. So it means that the height has also been given to be what? 1 meter. That is from here to here to be 1 meter. So I can have something like this to act as the height, which is 1 meter from the question. So now, if from here to here is 1 meter at the bottom, so at the top from here to here will also be 1 meter. So if I have from here to here to be 1 meter, it means from here to here will be 1 also 1 meter, and from here to here will also be 1 meter. So if you add this to give us this. So I haven't done that, the equation is solved. So what is remaining for us to do is to know this length from this point to this point. So we use so we're going to use Pythagoras theorem to solve for this length, the longest length, because we already have a right angle triangle which have been formed. So from here to here is 1 meter, from here to here is also 1 meter. Please take note, this drawing is not to scale. So let's call this point from here to here to be x. So it means we are going to have s square is equals to 1 square plus 1 square, right? Which is equals to 1 square plus 1 square is 1 square is 1. 1 square is also what? 1, which is equals to what? 2. So for us to get square, for us to get x, we have s is equals to square root of what? 2, which is equals to what? Square root of 2 will give us 1.41. So it means from here to here is 1.41. Now we have known here, the equation is solved. So what we need to do now is this. We have to know the total length from here to here, from here to here, and from here to here. So the length is equals to 1.41 plus 1.41. That is this and this plus what? 1. This will give us, let's add, this will give us what? This is giving us 3.82 meter. So I've known the total length. So for us to solve for the volume, I have to now do this. Volume now becomes, let me call it volume 1. I'm going to call it volume 1 because I'm looking for just the volume of concrete here and not at this point. So I'm calling it volume 1. So we have 3.82 times the thickness of this wall is 0.1 times the length at which this wall is running across, which is 10 meter times 10. So all this in meter cube. So this is equals to what? This will give us, this is still giving us 3.82 meter cube. So now I've known the concrete at this point. So what is remaining for us to do is the concrete here. The concrete here. So you can now see that for us to, let's use this one to calculate for this one and multiply whatever we have by 2. So for here, the volume of concrete, let's call it volume 2, will be equals to, you see this place, after bisect it, you see that from here to here is longer than from here to here. This thing is like this. There's a slanting something here. So we have to add this and this and find the average. So we have 0.25 plus 0.2 divided by 2. Whatever we have to multiply it by 0.2. We are now already having the area of this shape. So if you multiply whatever you have by 10, you're already having the volume of this place, the concrete here, because it's spanning across 10 meter. So I haven't done that. So I have to proceed. 0.25 plus 0.2 divided by 2 is giving us 0.45 times 0.2 times 10. This is equal to 0.45 times 0.2 times 10 is giving us what? It's given us 0.9 meter cube. So we have known the concrete here. So we have to multiply by 2 to cover for the concrete here. So when you multiply this by 2, we're having 1.80 meter cube. So this is for volume 2. So I haven't done this. The next thing is to calculate for the total volume. The total volume will now become, the first volume was what? The first volume was 3.82 plus the second volume was 1.80 or a meter cube. So when you add this and this, it will be giving you having 5.62 meter cube. So this is the volume of concrete for this trapezoidal drain with the following dimensions for 10 meter length of it.